Many of my videos are more bizarre and mystical, right? They kind of turn ineffable really fast just because of the nature of this condition I have, this anythingness. It's like it's so boundless that even calling it boundless or anythingness just is inadequate. I mean, those terms fall just as short as any other term. Even if they technically get closer, it's like that distance that they get a bit closer is just completely negated by how far away they are. They might as well be equal. So really, they do no better of a job at labeling it or pointing at it than even a term like the color green does. So for that reason, the topics tend to be kind of out there, needless to say. But if you haven't noticed, sometimes I also like to dial in and discuss more specific topics. Now, the thing with this dialing in, as I call it, which I'll explain more in a future video, I'm not going to have time to explain it here, is that due to the nature of the condition I have, this dialing in is not always going to be correct, right? I mean, if anything and everything can happen, then it could happen such that I dial in on a topic incorrectly. So everything that I'm about to share here in this video is not immune to that potentiality, right? It is possible that everything I'm about to discuss is wrong. But nevertheless, it's best to always throw an insight out there so that other people can kind of look at it and collaborate with it or work with it. Maybe they can utilize it in some fashion, whether or not it's right or wrong. So kind of just insert the insight into the thought market and people will do with it what they can. If anything, this is also an idea that I'm going to run by a couple of physics professors just so that I can check if, first of all, the idea is actually original, right? There's no point in sharing an idea if somebody else has already shared it. Or worse yet, it could be unoriginal and something that's already been disproven, in which case it's just completely useless. So this is not a topic to get all SD yellow and turquoise or mystical about. No, this video is something that needs to be taken on a very empirical basis. We're being very SD orange, so to speak. I really hate the fact that I have to reference spiral dynamics just to talk about these topics in their own proper context. I'm going to do a video more on that subject in the future, but there are cases, there are times in which it is best to not be quote unquote second tier. This whole idea that that's like better in all cases, it's flawed. Yes, obviously, it's better in many cases to look at multiple perspectives, but when we're looking at a purely scientific topic, like for example, studying the movements of atoms, it's like there's only one measurement that's going to take place. There's no room for multi-perspectivism there unless you're trying to get into the metaphysics of it, right? Like if you're getting metaphysical about it and trying to understand, what's the metaphysical reason that the atoms are moving like that, then yeah, sure, you can take a higher approach with that. But if we're just measuring things empirically and scientifically, right? I mean, the atoms are only going to move in one type of way during that one specific experiment unless you're changing all the conditions. Then they're going to move in another way. A vaccine is either going to work or it's not, right? Now, yeah, sure, there's shades of gray. Maybe it'll have like a certain percentage of efficacy, like 50%, or maybe it'll have a higher percentage of efficacy, like 95%. But point is, you can't just be like, oh, maybe cyanide will be a good vaccine for us. Like, there's no room for that sort of multi-perspectivism. When you're talking about purely scientific subjects, it is best to be more linear. So this video, for that reason, is going to be different than most of my other videos. A lot of my other videos are very mystical, very ineffable, and you can't really speak by the end of them. But this one is going to be much more purely empirical, very specific, very speculative, intellectual, and you could say very theoretical. Right? So I'm sharing an idea here that I've dialed in on, which may actually just be wrong, but I'll share it just in case, right? I've dialed in on many ideas in the past that turned out to be wrong. So this one is not immune to that. But this specific idea that I will be talking about in this video is a cosmological model that I have for the shape of the universe. And by the universe here, again, we're being very empirical, very quote-unquote stage orange. I really, really don't like how I have to keep referencing that. But we're being very stage orange here. So by cosmos, we simply mean, the thing that this Earth exists in. You can talk all day long about whether the Earth is real or whether it's illusory or whether you're imagining it or whether it's metaphysically this way or that way. But at the end of the day, you're still having this experience where you're standing on a round Earth. There's no room to be multi-perspectival and say, well, it's flat too. No. Even if it is flat, you're still experiencing it as round. So empirically speaking, you're on a round Earth. That's just a scientific fact. So same case, this round Earth that you're experiencing, you're also experiencing it floating in a thing we label outer space. And outer space has a very specific set of empirical features. So we've got to be very scientific with this topic. We are being narrow-minded on purpose here, because that's the point of this subject. It has this narrow context for a reason. Again, when talking about how to develop vaccines or other scientific subjects, things are supposed to be narrow. We're not talking about metaphysics here. We're talking about very specific cases for how things are experienced in the world. Empirically, right? Sensory-based. That's what science is. It looks at things empirically. So when I talk about the shape of the universe in this video, I am not talking about, oh, what's the shape of all of reality? Like what's the metaphysical nature of the universe? No, I'm talking about the nature of the cosmos as in the nature of the empirical space that includes this thing which we're standing on, which we experience to be a round planet, right? You're experiencing a round Earth. That is the shape of the Earth as you experience it. So we're talking in this video about what the shape of the cosmos is as you experience it empirically, purely scientifically, purely stage orange. That's the context. All right, now that I've laid that down, again, remember, all of this could be wrong, right? I could have dialed in on a scientific insight here that ends up being scientifically disproven. But I do think it's worth putting out there just in case it could potentially lend something useful. So what is the shape of the universe? Okay, well, ironically, in talking about the shape of the Earth as I just did, there is a sort of similarity in this model. And again, remember, this is a model. It hasn't been proven. This is something I still need to get tested if it's even original. And this is actually, I think, my first actually testable idea that I've had, at least in this life as Ethan. The first testable one. So I still have to get this tested in some way. Maybe it gets proven, maybe it gets disproven, but until then, regard this as simply a model. Again, we are being purely stage orange, purely empirical, purely scientific. That is the best genuine context for this topic. So the shape of the universe in this model has some similarities to the shape of the Earth as we experience it. You here, having this human experience, are on the surface of this round sphere that is the Earth. Now, the very top surface of the Earth is two-dimensional. I'm not talking about like the very top layer of soil. No, that still has some amount of depth. So that's still three-dimensional. I'm talking about the very, very, very top surface. Like no depth, no soil, just the very mathematical surface itself. That has no depth, that's two-dimensional. So you have this two-dimensional surface wrapped around this three-dimensional sphere, and that's the nature of the shape of the Earth that you are standing on right now, or sitting on, what have you. But now with this cosmological model that I'm pitching here, we take that one dimension higher. So similar to how the surface of the Earth is a two-dimensional surface of a three-dimensional object, what I'm saying here is that the cosmos that we are experiencing being inside of right now, this is a three-dimensional surface on a four-dimensional object. It's a four-dimensional sphere, otherwise known as a hypersphere. Now, this part of my model definitely is not original. There's been many hypersphere models proposed by lots of physicists. So we're just starting off here. We have not yet gotten into any of the aspects of my model which may potentially be original. This part right here is completely unoriginal. This has already been proposed. That we are in this three-dimensional space, and this three-dimensional space is the surface of a four-dimensional hypersphere. But now with that said, here's where my model does tend to kind of branch off and get different than a lot of those other ones, at least the ones that I know of so far. In that usually hypersphere models say that we're on this surface and we could think of this surface as being like the present moment. So like if we were to move below the surface, think like if you dug beneath the surface of the Earth, you would move closer to the core of the Earth. Instead, if we were to do the same thing with the cosmos somehow, if we were to somehow be able to dig beneath that cosmological surface, we would move to the center of this hypersphere, which would be the Big Bang, 13.8 billion years ago. So like you would start moving through four dimensions of space-time, so you would end up actually traveling backwards in time towards the Big Bang. So essentially the Big Bang is the center of the universe in the same way that the Earth has a hot, fiery core at its center. The difference obviously being that, well, the core of the Earth exists in the same present moment as the surface of the Earth, whereas with this four-dimensional hypersphere cosmos, its core does not exist in the same present moment. In the fourth dimension of space-time, they exist simultaneously. But with regards to this three-dimensional perspective that we're experiencing, they do not exist simultaneously. Instead, the Big Bang happened back in the past, and this surface we are in now, this is what exists. And this is the only thing that exists in many hypersphere models. The Big Bang does not exist anymore. Right, so it's like it's the core of this hypersphere, but it's not really there anymore. None of the other past moments in time are there anymore. So essentially this hypersphere is empty in most cosmological models. Where my model is different is that mine says, no, the core is actually still there. The Big Bang actually still exists. It's in the past relative to our perspective, but in this hypersphere, it's actually still there. This hypersphere is four-dimensional, so every past moment still exists. So the core is still there. The Big Bang still exists. It's like this frozen point in time at the center of this hypersphere. And furthermore, radiating out from that center are each of the past moments in time before this one, yet after the Big Bang. So think of each moment in time as like a surface of a different layer. You know, like the Earth has multiple layers going down to the core, and each of those layers, you could say, like has like a surface. Like if you were to picture in your mind, the top of the mantle is a surface, and if you go down further, the top of the core is a surface. You could even get more divisive than that. You could divide up the mantle in half, and the bottom half of the mantle is going to have a top surface, mathematically speaking, right? And then the lower third of the Earth's core, that lower third is mathematically speaking going to have a top surface, right? So we can really divide up the surface layers, not necessarily endlessly. Technically we could, but I'll get into that more later. But point is, you can keep divvying them up. So in the same way, yes, here we are in this present moment, which is one surface, but beneath this present moment, the past moments still exist as other surfaces below this one, yet above the core, which is the Big Bang. So the past still exists. Furthermore, in my model, the future already exists. So we are actually not the topmost surface. So don't think of us as being like the surface of the Earth, like on top of it. Rather, we're like one of the surfaces that's still inside of the Earth, above the core, but not up at sea level. Analogously, we're not like that. In fact, we're so far inwards that we're barely outside of the center. We're barely far away from the Big Bang. Because basically, if the heat death of the universe is going to be its actual end, this has not been fully proven yet, but this is the most supported notion for what the end of this cosmos is going to be like, is that there's going to be this heat death which occurs as the cosmos expands. You know, the heat's going to sort of eventually reach a point of maximum entropy, and there's going to be no more energy, no more heat. Everything's just going to reach a maximum state of equilibrium, so that's why it's called the heat death. Now, this heat death is predicted to occur 10 to the power of 100 years from now. That's a Google, for those of you who have heard of that famous number, excuse me, where the actual name for the number is 10 duotrigintillion. I probably mispronounced that, but that's the way I tend to say it. Hopefully that's correct. 10 duotrigintillion years from now, this heat death will occur. It's only been 13.8 billion years since the Big Bang. That is 13.8 times 10 to the power of 9. 10 to the power of 9 is nowhere remotely close to being as large as 10 to the power of 100. So if in my model the heat death occurs 10 to the power of 100 years from now, and it's only been 13.8 times 10 to the power of 9 years since the Big Bang, that means we have many, many, many more surfaces beyond the surface that is this present moment, right? The distance between the center and our surface is fractionally small compared to the distance between this surface and all the other future surfaces or other future points in time that are to come. You know, 10 to the 9 compared to 10 to the 100, that's like if you were to zoom out, we would look like we're actually still in the center. We're that close to it, analogously speaking. So if we were to compare our place in the cosmos to the Earth in this hypersphere analogy, we would be nowhere close to sea level. We would not even be in the mantle. Hell, we would not even be in the outer core. We would be in the inner core, and in fact, so far in the inner core that we are still basically right on top of the center, which is the Big Bang, because it was only 13.8 billion years ago compared to an overall timeline of 10 to the power of 100 years. Now, you might ask, Ethan, in your model, what exists beyond that outer surface that's 10 to the power of 100 years from now? Well, that would be the circumference, and there would be no outside. Now, this will sound confusing, like, well, wait a minute, Ethan, isn't reality infinite? Doesn't go on forever? No, remember, when I say reality is infinite, I mean that it's so infinite that it could be finite, and in fact, it might even be completely wrong when I say that reality is infinite, such that I don't know if it's infinite. This is why I say I don't know a lot. This is why I emphasize the not knowing aspect of my condition, because even if my condition accurately reflects the nature of reality, it admits of itself that it could be wrong because it includes its own negation, right? It's like a Ouroboros, it bites its own tail. So even if it's correct that reality is infinite, it could still be finite because it's not bounded to being infinite. It could be any which way. It could be finite, could be beyond infinite, could be something else entirely. And that's speaking for reality as a whole. But we're not doing that in this video. We're not talking about reality as a whole. We're simply talking about this cosmos, you know, the thing you see when you look up into the night sky. That cosmos could certainly be finite, even if reality as a whole is infinite. So don't be afraid or weirded out by this notion that the cosmos has like this outer circumference, 10 to the power of 100 years from now, and then there is no going beyond that. Like, it's just completely finite. Again, we're taking a very narrow-minded view here for a reason. This is a very scientific subject. There's only a finite number of ways that a vaccine is going to work. So yes, we are being finite here. We are being narrow. So looking at this hypersphere model, the outer circumference of the cosmos is this point in the future, 10 to the power of 100 years from the surface that we are on right now. It already exists. So time effectively is an illusion, or at least the passing of time is an illusion, because the past which you've experienced still exists, and the future, which hasn't even been realized yet, that already exists. So the passage of time is sequential, and in that sense, you could sort of say it's illusory, but we'll get into why exactly that perceptual sequence of events happens later in discussing this model. So really, that's how far out the cosmos extends in this hypersphere. You don't go any further out than 10 to the power of 100. In fact, the notion of beyond doesn't even really make sense anymore. It kind of becomes meaningless to talk about there being a space outside of that outermost circumference, because as soon as entropy is maximized, as it would be at the heat death, that outer circumference is the heat death, and at that heat death, everything exists in a state of equilibrium. So there's no energy moving back and forth anymore. Things are in complete stillness. And if they're in complete stillness and there's no energy or any activity moving back and forth, there's no time, and really then there's no distance, like there's no scale anymore. In fact, this part of my model, this is not original either. I'm actually talking about something here which a lot of physicists accept. A lot of physicists are accepting of the idea that if you maximize entropy, you are going to get this perfect stillness where there is no activity, there is no energy, and therefore talking about things happening like time, it basically becomes meaningless. The notion of time becomes meaningless, and time and space are essentially one fabric, as Einstein showed us. So if time becomes meaningless, then we no longer have any scale for things, and we no longer have any space existing in any meaningful context. So as soon as you move to this outermost circumference of the cosmos, 10 to the power of 100 years from now, you reach the point in time, the point in the future, where the heat death occurs, and beyond that, entropy is maximized such that time and space become meaningless. They become meaningless. And so if space becomes meaningless as a concept, then the notion of moving spatially further beyond this hypersphere model, it's meaningless. It doesn't make sense. Like there is no beyond it. Again, it's purely finite. There is no space beyond this four-dimensional hypersphere. It extends out 10 to the power of 100 years from now, and then it just abruptly ends. Not like a wall. See, that's where this gets really, really weird, is normally people think, okay, if something ends, that means one of two things. That means either it's like a wall and there's something further beyond it, right? Like there's an outside, or there is no outside, therefore it just abruptly ends. You just smack the wall and there is no going further. There's actually infinitely many other options besides just those two, which you cannot imagine, right? Obviously, the only two that you're going to be able to imagine are either, okay, we reach this boundary and then we can just move further beyond it, or no, we can't move further beyond it, therefore we just smack into a wall and we're done. But no, the universe, and especially reality, can get far stranger than that. Reality does not have to conform to the measly little thoughts of the human brain. Just because the human brain cannot imagine a third or fourth or fifth option does not mean that those options aren't possible. So no, this outer circumference, it's not an abrupt wall, but it's also not a boundary that you can just move beyond. It's literally just that space becomes meaningless. Talking about it abruptly ending doesn't make sense because that's a spatial concept, and talking about moving further beyond it, that's a spatial concept, so that's not applicable either. That's also meaningless. Ironically, we're getting kind of zen right now, even though I said this video is not supposed to be mystical, but you will find some concepts in physics that sound a little bit mystical like this. sound a little bit woo-woo just because they're so strange and counterintuitive. So yeah, you'll find it here and there, not just in what I'm discussing right now, but in many other topics out there. I mean, that's why quantum mechanics appears so strange to people. But back to this topic, if all these surfaces exist, you have this inner center, which is the Big Bang, and then you have all these radiating surfaces and all these points in time going out to this circumference, which is the heat death, which relative to us here in this present moment will occur 10 to the power of 100 years from now. Okay, if that all exists together simultaneously, such that the past still exists and the future already exists, then why do we experience time sequentially? Why do we experience it as, okay, the past happened before, now we're here in the present moment, and the future is going to happen next? What's with that sequencing of events if it all exists in unison, together, in a unified fashion? Okay, well, I'll explain this next. Okay, so think about it like this. Entropy is always increasing. Let me point this out. This is also not original to me. This is just sort of basic, like 6th grade science, right? Everything you do increases entropy. It increases disorder. It brings things to a further state of equilibrium. So if entropy is always increasing, then in the past, there was less entropy. And in the future, there will be more entropy. Again, that's why you end up at the heat death, in which there's maximum entropy. You get more and more entropy at each point in the future until you reach maximum entropy, which is the heat death. There's no more energy moving back and forth. Time becomes meaningless, and space becomes meaningless. Okay, so another word for entropy is disorder. So essentially, because entropy increases over time, that means that disorder increases over time. In other words, systems get more complex. So like, think about scrambling an egg. This is an example that a lot of physicists use. You know, compare the state of an unscrambled egg to the state of a scrambled egg. The scrambled egg has higher entropy than the unscrambled egg because, speaking in layman's terms, the scrambled egg is more chaotic, right? Like, it's more mixed up. But in non-layman terms, it's not simply that it's just more mixed up and more chaotic. It's that precisely because it's more chaotic, it takes more binary answers, like quote unquote yes/no answers, to really define the state that the scrambled egg is in. Whereas with the unscrambled egg, things are kind of just more, you know, orderly, right? Like, it doesn't take as much to really define it. You know, I guess, think of, if you want a simple example, think of the difference between a triangle, which is like a very orderly, simple shape with 3 sides, versus a shape that's sort of just like an amorphous, bubbly cloud. Like, it's harder to answer how many sides that shape has. It's harder to really define what it is because there's more going on there. That's kind of just a simple example. And again, I'm no expert in physics. I'm just sharing ideas here. So an actual physicist would probably be able to better clarify what's going on there, but that's just a sort of simplified way of putting it. You know, something that's more orderly and simple, it's easier to define than something that's less orderly and more chaotic. That's harder to define. In other words, things that are more disordered and more chaotic, because they are harder to define, it takes more information to define what they're like. It takes more information to define the nature of an amorphous cloud than it does to define the nature of a triangle. The triangle is very simple. It doesn't take that much information to define it. An amorphous, bubbling cloud takes a lot more information to really say what's going on there. So back to the point, as entropy increases, disorder increases, and as disorder increases, information increases. Because again, remember, as things become more disordered, it takes more information to define them. So information increases as well. This is actually not original to me either. You'll notice that I keep pointing out steps in this model that are not original to me, as opposed to other aspects which might be original. You know, I have to get them checked to make sure they really are, but I'll certainly point out to you each of the aspects of this model which are already accepted and mainstream, and certainly the notion that entropy increases and that entropy means increasing disorder and increasing information. This is all not new. This is all mainstream. This is all accepted. So as we move further through time, information increases because disorder increases, because entropy increases. So every surface beneath ours in this model that I'm proposing, they're all past moments in time. So they are points in time where there's less entropy, less disorder, and therefore less information. All the surfaces above this one, they have more entropy, more disorder, and therefore more information. Now, since we're being very narrow-minded on purpose in this video, let's look at classical logic. I talk about a lot of contradictions on this channel that break classical logic, but let's not allow contradictions here. Let's be very logical and very rational and very narrow-minded on purpose. So if we're being very logical and rational, meaning not allowing for contradictions, is it possible for a state of less information to include a state of more information? It's kind of like asking, can a computer which can hold 12 gigs of data, can that computer store a file that's 50 gigs? No, less information cannot contain more information. A smaller thing cannot contain a bigger thing, right? Again, logically speaking, obviously, I would say yes, that is possible, because there are things that break classical logic such that a smaller thing can, in a contradictory fashion, include a larger thing, but we're not talking irrationally or metaphysically here. We are talking in a purely scientific, logical manner, like how we would if we were trying to develop effective vaccines. Stuff like that. By the way, please don't politicize my vaccine examples. I'm not trying to make a political statement. I'm simply just using a scientific example that's supposed to demonstrate why linear thinking helps with efficacy and scientific advancement. Don't politicize those examples. But anyways, we have to think logically with these scientific subjects. So logically speaking, can we have a smaller thing contain a larger thing? No. We cannot have a state of less information containing a state of more information. So what this means is that the past surfaces in this hypersphere model of mine, they are states of less information. Therefore, they cannot contain our state. Our state has more information than theirs because we are at a point in their future, right? Our surface, it's the present to us here, but it's the future relative to those past points. So relative to them, we're in the future and we are at a higher state of entropy. Therefore, we have more information in the cosmos. We have more information, they have less information, therefore they cannot contain us. Each surface can only contain the surfaces that have less information than them. Again, a computer with 12 gigs of data, it can hold an 11 gig file, but it can't hold a 50 gig file. So each surface in this hypersphere can hold all the past points in time because they all have less information. It cannot hold all the future points, and in fact, it can't even hold itself, right? Can a thing contain itself? Well, yes, if we're allowing for contradictions, yes, a thing can contain itself, but we're being purely scientific and logical here. And in that context, is it possible for a thing to contain itself? No, a thing is able to contain things smaller than itself, but it cannot contain things equal to itself or larger than itself. So each surface is only able to contain the past surfaces. It cannot contain the future surfaces or even its own present surface. And this precisely is what gives us the experienced perception of time. The Big Bang, right, the core of this hypersphere, it cannot contain any other surfaces. Well, I mean, there's no surfaces beneath it, right? It's the center. So that's experienced. And then as soon as that's experienced, you now have more information that gradates you up to the first surface, which includes the Big Bang. But that first surface can only contain the center. It can only contain the Big Bang. It cannot contain any later points in time. It also cannot contain itself. So relative to that first surface, the only thing that has ever happened so far is the Big Bang. Its own surface has not happened yet, and none of the later surfaces have happened yet because those cannot be contained. It can only contain the Big Bang. So to that surface, the only thing that has perceptually ever occurred is the Big Bang, the past. But then now you have more information, so now you can gradate up to the second surface. And relative to that second surface, both the Big Bang and the first surface exist. They've happened. They're the past. But it cannot contain itself, and it cannot contain the future surfaces, so none of those have happened yet. Notice that there's something weird here about the nature of the present. Like the present is essentially ungraspable. It's like as soon as you grasp the present moment, it's gone. It's already the past, because each surface in time cannot grasp itself, right? The present cannot grasp itself. This also ironically gets a bit Zen and mystical, even though we're being purely scientific, in that as soon as you grasp the present moment, it's the past. Right? Because to grasp something means to make it grasped, past tense. So as soon as you grasp it, you've grasped it past tense, and therefore it is the past. It is no longer the present. In other words, the present can never be grasped. You see how that gets very Zen? And the reason why the present can never be grasped is because of this perceptual nature of time. That each of these surfaces in this sphere, if I'm correct, they exist and they can only contain the lower states of information. They cannot contain themselves and they cannot contain the higher states. And so because they only contain the lower states, to each surface, it's only the lower states that exist. It's only the past moments which exist and have already happened. The present has not happened yet. It's happening. And as soon as it's happened, so it's past tense, right? So it's not grasping itself. It's grasping it only once it becomes the past. But then it's not the present anymore. So to each surface of time, it's only the past moments which exist. It's only the lower states of entropy which exist. And because it's only those surfaces which exist, it's only the past which exists. And it is therefore only the past which has ever happened. The future appears to have not occurred yet because the future surfaces do not exist within the surface that you're at, right? So this is what creates the perception of time. It's essentially entropy. It's these increasing levels or surfaces of information, and the fact that each level cannot contain higher ones or even its own surface. So the future does not exist yet perceptually for that reason, because those levels of information cannot be contained, and the present cannot contain itself, so it hasn't happened yet. Instead, it's happening. It's only all the past surfaces of lower information. It's only those that exist. It's only those that have occurred. So we see the past. We essentially only ever see the past. You know, if you know the speed of light, you'll know that the speed of light is finite, right? So it takes time for light to travel. Even if you're looking at like an object only a foot away from you, it takes some tiny fraction of a second for the light from that object to reach you such that you see the object. So you're not actually seeing the object as it is in the very present moment. You're seeing it as it was a tiny fraction of a second ago. In other words, you're seeing it as it was in the past. So you're always seeing the past. You're never seeing the present. You're never grasping the present, right? As soon as you grasp it, it's gone. It's the past. The present is elusive. It's vanishing. It's like a ghost. And that's because of each of these levels of information, at least That's the answer my model would give. We'll see if that's correct. But I won't bog you down too much more. There's other things I would like to say about how black holes work in my model. That's a very strange answer that it provides. And also how general relativity works. Why does heavier gravity make time move slower, right? Why does less gravity make time move faster? This has been measured, right? If you're closer to the center of the Earth, like at sea level, the clocks will move slower. We've measured this and tested this with atomic clocks, and a person standing on a mountaintop, they're further away from the center of the Earth. There's slightly less gravity, and so time moves slightly faster. Why does that occur? Why does time come in this sort of flexible package in that way? Well, my model provides an answer to that as well. Again, all these ideas, they could be wrong, but I'm just putting them out there to hopefully maybe get them tested at some point, and we'll see if they contribute something or not. Let me know if you have any questions. This probably got pretty confusing since this is not a typical video, but hopefully you enjoyed it nonetheless. Create a nice day.